Okay, so most of you have heard of type 1 diabetes and may even know someone that's affected by this disease. So it's a highly investigated disease, yet it remains an unmet clinical challenge. This image is supposed to represent the prevalence of type 1 diabetes, and it doesn't discriminate between age or gender or ethnicity, and it highlights the point that it is one of the largest medical and socioeconomic burdens that we face until a cure is actually established. So as healthy individuals, and Freddie did a really great job on describing the pathogenesis of the disease, so I won't beat a dead horse. But basically, when type 1 diabetes occurs, there's an autoimmune destruction of the beta cells within the pancreatic islets, which are a bundle of cells. And together, without these beta cells, we have we don't maintain our blood levels, like our blood glucose levels, that is. So the current strategies for therapies and maintenance of blood glucose levels right now is the exogenous insulin that patients become dependent on. There's other supplements and dietary regulation. However, none of these are able to actually prevent long-term complications. So the Diabetes Research Institute here at UM has a large initiative that drives leading-edge approaches to curing type 1 diabetes. And this is by ongoing trials where they use cell replacement therapies where they introduce a donor's pancreatic islets to the actual type 1 diabetic patients. Now, this may seem really straightforward. However, there are many limitations to this approach. It's on the leading edge cusp of medicine where this can provide a potential cure. So in order for us to overcome many of these limitations, we're proposing a modeling of islet transplantation, and I'm also, as a stem cell biologist, proposing the use of mesenchymal stem cells to be added to the transplant of pancreatic islets to improve many of these things that could help optimize this transplantation process. In order for us to have a long-term viable function of the pancreatic islets, there are many things that we need to overcome. So we need to find the right transplantation site. These pancreatic islets require high levels of oxygen, and they need to be closely associated to the bloodstream or the vasculature. Therefore, integration with the surrounding vasculature is a critical process, and this is called vasculogenesis. Another big limitation is how the patient's immune system will actually accept the graft. So fortunately, with the addition of mesenchymal stem cells, these cells are unique and they maintain homeostasis, so they're capable of promoting an anti-inflammatory, immunomodulatory, and even a vasculogenic effect when introduced to this system. So using this lab-on-chip devices and in vitro platforms, such as this model for transplantation, allows for pertinent tissues and cellular components to be evaluated with ease of sampling and high-throughput analyses, and ultimately address the evaluation. So let me go through this quickly since I'm running out of time, but we have preliminary results to show that with islets alone, which is the current strategy, or what's called a heterotopic islet spheroid, which introduces the stem cells and also endothelial cells, we can add this to the transplantation site, which is our vascular bed, and we can start to see some small improvements. This is the islets alone, and then here is what we have when we actually have the heterotopic islet spheroid that's mediated with the stem cells. Thank you.